It's the question literally everyone is asking right now. Every single time we open a news app or scroll through social media, there's another headline about artificial intelligence. And let's be honest, a lot of those headlines are practically shouting that human workers are about to become completely obsolete. There's this widespread anxiety that we're basically witnessing the end of jobs as we know them. But what if we're looking at this entirely backwards? What if instead of an ending, we are standing at the absolute beginning of the most massive industrial expansion in human history?
Welcome to This Explainer. Today we're going to cut through all that doom and gloom and actually break down the mechanics of what is happening in the tech world right now. We're going to be drawing on some fascinating insights from NVIDIA CEO Jensen Huang, who, by the way, is the man whose hardware is literally powering this entire revolution. We're going to explore how artificial intelligence isn't just some cool software trick anymore, but is rapidly becoming the largest manufacturing industry the world has ever seen. Except it doesn't produce steel or cars, it produces intelligence. We're talking about the intelligent industrial revolution.
So, here is our roadmap for today. First, we'll look at the eras of modern computing. Second, CPUs versus GPU deep learning. Third, the rise of agentic AI. Fourth, the new industrial revolution. And finally, AI's impact on jobs. Okay, let's dive right into this with Section 1, Eras of Modern Computing, a history of technological shifts. To really understand where we are going, we have to look at the massive computing shifts that actually brought us here, right? Because we didn't just arrive at AI overnight. Back in 1995, we had the PC internet age. This was the era of Windows 95 and those early web portals, which fulfilled that huge vision of putting a computer on every single desk. Then, you jump to 2007, the mobile cloud revolution. The iPhone literally put an internet device into every pocket, connecting billions of people to this massive world of apps. But our current era, the AI era, that was quietly sparked back in 2012. That was the year of the GPU deep learning Big Bang, basically when a neural network trained on GPUs completely shattered records in image recognition. That exact moment proved that if you feed a massive artificial brain enough data, it can actually learn to perceive the world. Moving on to Section 2, CPUs versus GPU deep learning, the hardware catalyst. To truly grasp the sheer scale of this third computing era, we need to understand the underlying technical shift powering it all. The hardware is the catalyst here. For decades, our entire digital world ran almost strictly on CPU computing. CPUs are built for instruction processing and sequential execution, basically doing things step by step. You can kind of think of them like super hyper-organized middle managers. And in the cloud era, the business model was really just renting out these CPU cores. But the AI era, it requires something totally different: GPU deep learning. GPUs are absolute beasts at massive data processing and pattern recognition. They don't just execute static instructions, they power complex neural networks. And this brilliantly illustrates the shift, because in this new economy, the main metric of output isn't renting a core anymore, it's generating tokens. The AI is essentially a factory now, and tokens, which you can picture as little digital puzzle pieces of words or images, are its manufactured product. And this leads us to a massive, honestly mind-bending conceptual leap. Historically, software engineers had to meticulously code every single algorithm line by excruciating line. If a programmer didn't explicitly write the rule, the computer simply couldn't do it. No way. But now, with deep learning, algorithms are learning from mountains of real-world examples. So instead of coding rigid instructions, we are training neural networks. The software is effectively writing itself based on the data it consumes. Which brings us to Section 3, the rise of agentic AI, unmetered intelligence. So what kind of crazy software capabilities are unlocked by these massive token-generating GPUs? Look, we've all played around with generative AI at this point, right? You ask it for a poem or a funny picture and it gives you one. But agentic AI? That is a whole different ballgame. It goes way beyond just generating static content. It actually generates thoughts, it can reason, it can plan, and absolutely crucial here, it can use external tools to complete complex, multi-step tasks totally autonomously. This is the big shift from a fun novelty chatbot to a highly useful digital worker. Let's actually walk through the iterative loop of how one of these autonomous agents works. When you give an agent a goal, it starts by reasoning about the problem. Next, it forms a concrete plan of action. Then, it actively uses tools, so things like searching a database, running a piece of code, or opening a web browser. But here's the absolute magic step. It evaluates its own work. If the result isn't quite right, it iterates. It loops back, tweaks its plan, and tries again until the job is fully done. It doesn't just sit there waiting for your next prompt. It takes an objective and just figures out how to achieve it. Now, what's really interesting about this is the sheer computational scale required to pull it off. Because these agents run autonomously, iterating and evaluating their own work for hours, days, or even a full week just to finish a massive software job. The computation required has grown 100 to 1,000 times compared to just a simple Google search. That is exactly why the global demand for AI infrastructure is currently going completely parabolic.
All right, let's look at Section 4, the new industrial revolution. AI in the physical world.
So far, we've talked a whole lot about data centers and software, but the real magic happens when we shift our focus to the physical world and we see how this immense computing power is completely transforming modern industrial processes. We are now seeing the totally tangible applications of physical AI. We have intelligent Internet of Things devices processing heavy data right out on the edge. In logistics, autonomous transport platforms are radically changing how vehicles perceive the environment around them. Massive enterprise AI supercomputers are being deployed to completely reimagine corporate workflows. And over in manufacturing, companies like the Japanese robotics giant Fanuc are literally building the factory of the future. They are using AI platforms to allow groups of industrial robots to actually learn physical motor skills together through trial and error. So AI isn't just trapped in your computer anymore, it is animating the actual physical machines that build our world. To really understand the economic stakes of this, just consider this number. $10 trillion. That is the size of the transportation market alone. AI platforms are entirely reimagining this sector, building open, highly scalable architectures for everything from simple highway cruising all the way up to fully autonomous shuttles. When you apply artificial intelligence to a $10 trillion physical industry, the ripple effects are just absolutely staggering.
Which brings us right to this incredibly visionary quote from NVIDIA CEO Jensen Huang. He notes that the production of intelligence will be much, much larger than the production of energy. Just stop and think about that for a second. Energy basically powers the entire modern world. It's a massively huge global industry. But the creation of digital intelligence, manufacturing these tokens of thought in massive AI data centers, that is poised to become the single largest manufacturing industry the world has literally ever seen.
Let's move to and see how this builds into Section 5, AI's impact on jobs, augmentation, and resurgence.
So, when it comes to the impact on our jobs, we honestly need an entirely new framing. First off, building the physical infrastructure for this AI revolution means trillions of dollars invested right here domestically. We are already seeing a massive resurgence in the demand for skilled craft labor. Plumbers, electricians, and construction workers are urgently needed to physically build these massive data centers. We're also seeing a huge expansion of traditional manufacturing and factory jobs. And for the white-collar workers, software engineers are being augmented, not replaced. With an AI agent happily handling all the routine, boring coding, engineers are going to spend their time actually problem-solving and orchestrating multiple agents at once. The big takeaway here is super clear. There is incredibly high employability for people who take the time to know how to use these AI tools.
As Jensen Huang puts it perfectly, telling young people AI is going to destroy opportunities for them is a disservice to society. AI creates jobs. The absolute core message here is that adapting to and utilizing AI is the real key to your future employability. You aren't going to lose your job to an AI. You might, however, lose it to a human who knows how to expertly use an AI. This technology is an augmenter of human ambition. It is definitely not a replacement for it.
So, we're going to conclude this explainer with a pretty provocative question. We are entering an era of unmetered intelligence, where the barriers to complex problem solving are dropping to basically near zero. Very soon, you will have a team of highly capable, totally tireless digital agents right at your fingertips. The hardware is built, the software is literally writing itself, and the new AI factories are coming online as we speak. The only variable left in this equation is human creativity. So, in a world of unmetered intelligence, what will you build?